Hello and welcome to the next video, which covers on-site connections and safety. So far we have covered the basics of measurements and equipment. Now we get to the part where you are ready to perform the actual connections on-site. This is the part where safety is of the utmost importance. When attempting to carry out the connections, ensure that you have the necessary PPE or personal protective equipment. The most obvious one is to wear specifically rated electrical gloves where the rating is at least 1000 volts and reach close to your elbows to ensure that no part of your arm come into contact with any live terminals or bus bars. Here's an example of the type of gloves that you would use for electrical safety. And as mentioned, minimum 1000 volts because you'd most likely be measuring low voltage installations, or if you're measuring at medium voltage, you're going to be measuring on a 110 volt voltage transformer as we discussed previously. Okay. It is also good to wear safety shoes with thick rubber soles to ensure good insulation of your body to ground. So safety shoes are also essential. Then your client may have requirements for hard hats and safety goggles, and those are also recommended to wear because you never know what type of dangers or hazards are going to be present when you are carrying out measurements. So ensure that you keep the gloves on until all connections have been made and you are satisfied that they are all secure. In almost all cases, customers would not allow you to switch off all power to do your connections, as it may interrupt their business operations or production. You will therefore have to do the connections live. Only when measuring houses or small businesses would they probably allow you to switch off for about 5 minutes. If that is the case, make sure that you first measure the live points with a multimeter to ensure that there is in fact voltage on those points. And after you switch off, then you can check the connection again and make sure that there is no voltage. Check it with your multimeter before you start doing the connections. Now make sure that you connect your voltages and current leads securely to your instrument first and foremost, and not after you have connected them to the live parts, that is the circuit breakers or your terminals in your panel. You will very likely end up getting an electrical shock if you do it the other way around. So it's always instrument first and then onto the live terminals. Now you are likely to encounter some issues when connecting the voltage and current. For voltage, finding a suitable, secure, safe and solid connection point can be difficult. With most clip-on connections, it is also likely to ensure that the connections are not weighed down by the weight of the wires, which could result in the clips coming off at any time. So here's an example that we've discussed previously of connecting to the bolt and nut of the bus bar. Now these crocodile or alligator clips need to be secure and not weighed down by the weight of this cable coming here. So I usually try and find a location on the side, perhaps on the side of the panel, and I try to cable tie that cable so I don't have too much cable hanging down here and too much weight on those crocodile or alligator clips. So it's very important to do that and always keep cable ties with you. So these photos now show points at which I have measured typically. Okay, so we've previously discussed this photo on the left. And if you have a look at this photo, these connections are very secure because they've been screwed into the terminals of the circuit breaker. So the weight of this cable is not going to really be an impact on those leads. You obviously want to make sure that your banana connections are in good condition. Now when we're looking at this connection here and using the micro clip, you're going to have the weight of the cable pulling that micro clip down. So in this case, a good spot to actually cable tie your lead would be up here, and then you could have your lead. So your lead would be coming down from the instrument, and you'd be hanging down here, and then you'd have your micro clip going onto there. So this is always essential to do it this way. Now, for current, also ensure that you keep your safety gloves on at all times. Sometimes getting to the feeder cable or wires may be hazardous, and your hands could come into close proximity to live parts. This is especially true if you are required to clamp onto bus bars that are slightly behind the circuit breaker. Have a look at this connection here. We have connections that are right at the back of the circuit breaker. This is the circuit breaker, and we are looking at the panel from the side. And these bus bars come up this way and then out this way. Now, connecting onto these cables could be very difficult and challenging. So you need to make sure that you have your PPE on and try to find a location to connect onto the bus bars where you are not close to any bus bars or live parts. It's a very delicate operation, and you have to be extremely careful. Now, if you are using a transducer that uses the existing panel CT secondary wires to obtain current readings, that's not too difficult. You would simply take your transducer, like we showed earlier, and connect it to the incoming or outgoing wire of the panel ammeter. So here we have your panel ammeters in the second photo, and if you notice, the transducer is connected, or it's put around the wire that goes into the ammeter. So that's carrying your 5 amp secondary from your CT. Now in this example, we have the 5 amp output of the secondary to the panel ammeters. Our transducer is 5 amp to 1 volt, as we discussed previously. The instrument software then converts the 1 volt back to a maximum 5 amp scale. This means that if the ammeter is on 2.5 amps, the transducer will deliver only 0.5 volts to the recorder. It is a linear scale. The instrument will then display as 2.5 amps or whatever CT ratio you have configured in the recorder. So let's assume that you have a CT ratio of 500 to 5 and your load is at 100 amp. So your secondary amps will be 1 amp and the transducer will give you 1/5 of 1 volt, which will be 0.2 volts. The instrument will then display 1 amp, or if the CT ratio is set in the instrument, will display the actual 100 amps. If you are using a clamp-on CT that came with the instrument, it is likely that it will be rated 100 amp or 250 amp or 500 or 1000 amp. In that case, you would have to firstly ensure that the rating of the CT can handle the maximum amps of the feeder. That is, it must be rated equal to or higher than the feeder circuit breaker. Now, we discussed this in a previous section when discussing the CTs. With these type of CTs, the instrument either automatically detects the rating, or you have to select from a preset list and the instrument will display the correct amps. The CT will also probably function like a transducer to get a small voltage or current into the instrument, but the conversion is all worked out in the software. So if you look at most instruments, perhaps your Fluke or Hioki instruments, they also operate like transducers. However, they're not 5 amp 1 volt. They may be 500 amp to a certain voltage, but they operate in a similar fashion. But those CTs are specifically made for the instrument and you can't use them in any other instrument. Now in my case, I have an instrument that works with the 5 amp 1 volt transducer. I also have variable CT clamps which can be adjusted to 250, 500 or 1000 to 5 amps. Now here's a picture of the kind of clamp-on CT that I have. And here at the bottom, on the one side, I have S1, then I have 250 amps here, and on the other side, other arm leg of the CT, I have a 500 and I have 1000 amp. So this bridge piece, there's a little bridge wire that goes between S1 and whatever ratio you want. So you could connect it if you want a 250 ratio. You connect it between S1 and 250, and if you want a 500 ratio, you connect it between S1 and 500, and if you want 1,000, you connect it between S1 and 1,000. Now what happens here? The bottom has a bridge wire, as I mentioned previously, that connects the S1 to the correct amps. Now, have a look at this photo on the right. In this photo, we have used the variable CT, and then we've connected the transducer. So the variable CT is connected onto the feeder cable, and then the transducer is connected onto the bridge piece. So assuming I had a 500 to 5 ratio on the variable CT, then I'm using the 5 amp to 1 volt transducer. So you understand how I'm actually doing my conversion of my voltages and my currents. Now another very important thing to remember. Let us go back 2 slides. Let us go back to this slide. Now if you have a look here, we have multiple cables that are going out on a single feeder, on a single phase rather. Now what happens in this case? The rating of the breaker might be too high. Let's assume it is 1,600 or 1,500 amps. Now that's way more than what a single cable can carry. So we're going to be using multiple cables here. Now in order to do a measurement here, it becomes quite difficult if your CT cannot go around this bus bar. And also if your CT ratio is a maximum of 1,000 amps, then you have a problem. However, if all these cables, all these outgoing feeder cables are the same size, and you've got to make sure that they are the same size, then you can connect to one of the feeder cables, and then in your ratio, you multiply your ratio by 3. So what happens here is, okay, if let's assume that each of these cables are exactly the same size. So what we can do is we can connect to one of these cables and we can use a ratio of 500 to 5 amps, and then we multiply that by 3. So our end result, when we get our data, we have to multiply our current by 3, or if your instrument allows you to put in the ratio, you can measure one cable but put a ratio of 1,500 to 5. Okay. Then your data will be correct. So it's important to note that you may not have the direction of the current flow correct when clamping the CTs. That is okay, but you must fix this before setting the recording and leaving the site. You will fix this by checking the displayed readings on your instrument. We will cover this in the next section when configuring the setup. All right. Let's go now to a recap. So we have discussed the correct PPE that is required for when you're carrying out measurements. We've talked about working live and doing voltage connections and all the safety requirements. And we've talked about working live and doing current connections. Now, and we've discussed as well the CT ratios. So in the next section, we are going to look at the configuration of your instrument on site. So this will be more of your software configuration and ensuring that your vectors are all correct. And then we will look at the final section, which is the reporting once you have all your data completed. Thank you, and I'll see you in the next video.